So, hello everyone. Great. So, we'll be introducing with this session, enhancing financial analytics with event-driven architectures and neural networking graph. It's going to be an interesting session to mainly focusing on the financial fraud analytics and why exactly graph database and this graph convolution neural network plays a pretty important role in case of financial analytics. So, before moving, a bit about me. I've already introduced. So I am currently the founder and CEO of InsightAI, which is a fintech AI company, specifically into early fraud detections and risk management. I have been working for around 9+ years around in fintech and industrial AI, being a graduate from IIT Kanpur. And I have been a renowned speaker around AI/ML and deep tech, fintech, etc. So moving down to our session. So I think the first question that comes up is like why exactly fraud analytics is such a big issue, or what exactly is the impact of like fraud analytics? See, financial fraud analytics is one of the primary issues that actually cause a loss to a lot of the banks or any kind of entities. If I start quantifying the numbers, so a loss of let's say even $12 million that is left undetected for a certain period of month or some time can lead up to 30 to 40% of losses, right? And the penalties that are caused because of these losses can actually go up to $120,000 per incident. So when I say incident, so basically whenever there's a fraud identified, first of all, there's a timeline that once the fraud has been identified, there's a timeline that is defined by the different governments of a country that, okay, within this much timeline, the fraud needs to be reported to the central bank or the regulating authority of the country. If that is failed, it can actually lead to huge amount of sanctions on the banks or the entities or any kind of fintech institution, and this can cost a lot amount of legal expenses, the revenue losses, and the most important problem that happens because of this is the decline in customer acquisition rate, because there's a lack of trust on the entities. Once there are a lot of once there are a lot of fraud or similar kind of cases that happen on a particular entity, and that's why fraud analytics is a very important issue that need to be, that requires an urgent dealing. So if there's a certain important issue, why exactly, like what are the current challenges in the financial analytics, and what exactly are companies doing to resolve that? Uh, the most important issue that happens in case of financial analytics is first of all the complex network. What does it mean by complex network? See, whenever there's a fraud analytics that needs to be done, the data is actually captured. Let's say the transactional data is captured in some of the SQL databases or similar kind of databases. The KYC data of a user is captured in a big database, and similarly, the historical data, what the transactions have happened previously, are also captured in similar kind of other databases. Then there are some unstructured data which can comprise the data like the call recordings, the messages, transactions, the emails, etc. These are unstructured data. Now, in order to actually understand a fraud or what are kind of transactions are happening, you need to consume all the data together and then analyze that, okay, whether exactly this particular transaction is fraud, what are the reasons for the fraud. So the complex network of fraud is complex data that is present. That is one of the main issues why it is difficult to identify the fraudulent transaction. So like identifying fraud is like identifying a needle in a haystack. It's that kind of issue that happens. Then second is fraud pattern analytics. Now, fraud pattern analytics is again a very important issue. So, see, in case of, let's say, if you have simple list of data and you have to identify that, okay, if there's an anomaly in one of them, let's say there's a sudden spike in the transaction, or there's a lower, or there are some small number of large transactions that are happening, then it is still much easier to understand. But a lot of times, in the cases of fraud or AML and the money laundering cases, how fraud actually happens is there's a network of fraud that happens. So basically, one account, there are multiple accounts that are linked together. One account does a transaction with the second account does with the third account, and then there's a repeated pattern that happens. Now, these kind of transactions are difficult, which cannot be easily identified by the regular databases. And that's why, or databases, or to be precise, the regular processes. And that's why this complex pattern is something that needs to be dealt with carefully in order to identify fraud. Third is around real-time analytics. Real-time analytics, I think this is something that like I have already discussed previously, that because of the delay in the fraud detection or delay in the report of a fraud to the central authority of a country or any entity, there are huge amount of sanctions that are imposed on a particular bank or any financial entity. And similarly, because of the delay in the fraud detection, there is also a loss in the there is also a loss of reputation for the bank. So because if a bank continuously has a lot of fraudulent transactions happening, it becomes difficult to customers for trust the bank. Third is around the data relations. So uh, data relations basically it's very important because in any kind of identifying a fraudulent transaction, you need to understand that okay, if one party is doing a transaction with the second party, and I need to understand that okay, if second party is not a blacklisted entity, right? So we need to be very careful that okay, where is the transaction happening, and is this a repeated transaction or a one in a million, one in 100 instance of transaction, right? So that's why data relations is very important to identify, which becomes a problem in identifying the fraudulent transaction. Complex queries. So complex queries, I think it's very well understood because if there is a complex network that is happening, if there are multiple bank account anomalies, etc., which are there, and I need to identify a transaction which is passing through all of them. If I do in a normal kind of database or a normal data pattern, so then I'll have to run multiple joins in order to understand okay how exactly are all these transactions linked. So that is again the complex query is one of the major issues why this particular financial fraud is difficult. Now, just to give an example, in order to identify, let's say, a money laundering transaction which happens in some of the large banks, just to identify in one instance, one case of a money laundering, there are nearly 30,000 queries that need to be run together because the data is huge. It's a historical data of 2 to 3 years that needs to be analyzed. It's a KYC data, it's a unstructured data, which needs to be compiled together. That is why the queries that have to be run are pretty complex. Finally, is the data anomaly. So data anomaly is the suspicious behavior in transaction. So suspicious behavior could be anything which could vary from country to country, right? So for example, there are terms like large reportable transactions, right? So for example, in some country, for example, in some developed nations, the large reportable transaction could be a larger amount, while in some developing nations, the large reportable transaction could be a lesser amount, right? Now, depending on the kind of area, the models actually need to adopt and it need to understand that okay, what is the kind of transaction that has to be defined as an anomaly and what is a regular transaction. So these are some of the major challenges. There are other challenges on top of that also which occurs on term in terms of the architecture alone, but these are some of the major challenges why fraud detection is very difficult or it needs to be done in a real time to make sure that the frauds are identified and reported in time to the central authorities. uh, now Now, the second, now just highlighting one specific part, which is the real-time fraud detection. Why real-time fraud detection is important, or what are the challenges in identifying real-time? Because fraud detection, definitely we know that okay, there are certain challenges around the queries and all, but since it has to be identified real-time, why real-time is important is because challenges in real-time is because the data volume is high. As you know that for any kind of fintech entity, be it a payment gateway or a bank, there's a high volume of data transaction happening, and the speed of the transactions is going on like anything because of the improvement in the fintech companies and all. And that is why it has become very important that the solution should be able to instantly, within the least amount of time, should identify whether a particular transaction is fraud or not. And second is around the rapidly evolving fraud tactics. Now, this is a very important thing. So, like, as the technology keeps on improving and as the fraud detection algorithm keeps on improving, even the scammers are going to improve with time. They're going to keep adapting to whatever the new identification methods are coming on, and they're going to very quickly adapt to that. And that is why it is very important that the any kind of solution that we are working on for fraud detection should be able to adapt to these kind of tactics. The accuracy and the data fragmentation issue. So accuracy issue. So when I say accuracy, here accuracy basically becomes an issue around false positive. So what do you mean by false positive? So false positive is basically the transactions that are not flagged yet have been flagged as fraud. Right now, this is one of the major issues. Why? Because if I quantify that in terms of numbers only, some of the largest banks of the world are actually losing around $67 million, 67 to $70 million because of this one specific issue, which is around the false positive. So what happens in false positive, like uh, whenever a set of transactions are provided, because most of the time these fraud algorithms run on rule engines that, okay, if there's a transaction, if there's an amount credited and instantly 90% of it is debited, then that particular transaction is defined as a fraud, right? But there might be cases where this rule might not apply, and hence it is actually not fraud but gets flagged as fraud. And this actually is one of the other issues that needs to be dealt for real-time analytics. And data fragmentation is something that we have defined, that since the data is siloed and stored at multiple places, being transactional at the SQL databases, uh, the KYC data, which includes in the big databases, etc., it becomes difficult to augment all the data together. So that is where we actually utilize the solution of graph databases, and how Neo4j actually plays a pretty important role for us in order to resolve this complex issue. So why graph databases play a very important role? So first is the fraudulent transaction is generally a network of multiple interconnected transactions, right? So which means that, like I said, that there are multiple accounts that are linked together, and the transaction is going from one account to another, and then it is repeatedly being copied between these transactions, repeatedly being replicated among these accounts, right? And that is where uh, uh, it needs to be identified that, okay, what are the fraud patterns? Now, in order to identify the fraud patterns, the graph databases are pretty important, because they can actually reflect, they can actually showcase the true nature of transaction that's happening, right? And since graph database like Neo4j has a pretty good entity relationship between the nodes and the transactions, so it's very well, the representation actually helps us to identify that, okay, these are the set of fraudulent transactions, fraudulent rings that are happening, right? So the benefits of using a graph database is identifying the hidden patterns and relationship, which cannot be identified by a normal SQL kind of databases. And second and most important is the complex queries that are run, right? Because for running any kind of complex queries, if the similar things need to be applied in a database, in a regular database, there has to be multiple joins, etc. Well, graph database actually are pretty good at understanding the queries, for example, in Neo4j, the cipher queries that actually helps to understand the relationship. And with a simpler queries, the data can be like these patterns can be easily understood. So what it helps us to do, so basically we are able to do the real-time relationship mapping between, so basically whatever event data, the transaction data comes to us, it can instantly be mapped within the node and entities, and can easily identify the fraudulent ring, can detect the layered transactions and all. So for example, a very specific example use cases where multiple accounts, multiple bank or different accounts are using the same device in order to execute a set of transactions, right? Or a particular account is linked to multiple devices, right? So these kind of things can be easily identified. Why? Because of the representation of the data that happens, because each node is either a device that defines that where the transaction is happening, or it defines a particular account, which could be like a credit card or a bank account that defines where the transaction is happening, right? So the overall benefit that actually comes from using a graph database and network database for financial fraud detection, first is the reduction in the false positive. So because we are uncovering, because in case of graph databases, since we are not just looking at one of the transaction, we are looking at the entire network of transaction which are peripheral to the transaction that we're looking at. That's why we are able to much better identify that, okay, is it exactly a fraudulent transaction? Is there a transaction happening to some unidentified party, which actually reduces the false positive to a lot, and that's where the accuracy increases. Secondly, there's a faster investigation process because the data can be consumed together and the process is faster. Third is the regulatory improvement in regulatory compliance, which is like a byproduct, which is like an implication of the first two. So once there's a decrease in the time of the fraud detection, and there's a higher accuracy, the regulatory compliances can be much faster worked upon, or can be actually followed better. So the first thing is like, how do we like in order to identify fraud via the graph databases, how exactly do we represent the data? So in order to represent, every node in the graph database is represented as an account, transaction, or account or a device, right? So it could be either a bank account, or it could be a device where the transaction is happening, right? Then the edges, the networks that link it, are basically the transactions that are happening between these devices or the accounts. So basically now we have been based on this particular set, we are able to create a network where there are multiple account or nodes which are linked to each other via the transactions that are happening. And in such cases, if there is a repeated transaction, or if there is a transaction that is happening from one device to multiple accounts, it can be easily visualized in the graph database, or it can actually be resolved via any kind of cipher queries that is done. Now, the most important part, how we actually convert that to a real time. So basically, real time actually happens with the event driven architecture. So in event driven architecture, how that works is any kind of action that is taken. So for example, be it a login into a particular device or an account, a transaction that happens, a chargeback that is initiated, etc. So each and every action that is triggered, every action that is there, it is triggered like an event, and this event is then passed on to the graph database, which is where then the graph convolution neural network instantly scores a particular transaction, and then identifies that, okay, whether with how much probability that this particular transaction is a fraudulent transaction. So we are going to see that in one of the slides next, where I will be describing it via a diagram. So let's move this. So yeah, and so that event driven architecture basically helps us to identify the similar transactions in real time. What are the benefits of event driven architecture? So first is the real time processing, because any kind of action that is taking place, be it a login attempt, be it a transaction, be it a chargeback, refund, X, anything, it's instantly triggered, given to a solution which identifies based on the network it is present in, that okay, whether it's a fraudulent transaction or not. Second is around the scalability, because since it's based on the number of events, so based depending on the kind of events that are coming in, the solution can easily be scaled up or scaled down. Flexibility and resilience, because it can be easily adapted to any kind of environment. So basically, it's not specific that okay, it's a whole suite of solution that because events can be integrated into the event setup can be integrated into any kind of transaction. So let's say if there's a banking transaction happening, it can be a part of that. If there's a chargeback solution that running, they can integrate the APIs there itself, and the events can be directly triggered. So it's easily adaptable to any kind of entity that we're working with. And finally, it's a cost-effective one. Why cost effective? Because in event driven architecture, the cost of resources is incurred only when an event is triggered, right? Which means that there is it does not have to be a continuous monitoring. The moment the events are triggered, it can easily scale up, and the resources are going to get utilized only then itself. So that is why it's a pretty cost effective way to identify the real time frauds, as well as to showcase to reduce the time for detection, right? Uh, so the key components that generally are utilized for an event-driven architecture, the first of all is going to be a event stream, a platform like Apache Kafka, which is able to stream any kind of real-time transaction to the graph databases. Secondly, it's going to be a ETL pipeline. So like we discussed that the graph database generally are represented in form of nodes and the edges as transactions, right? Now, in order for us to visualize that, the transactions that are coming needs to be mapped in a certain format so that it can be consumed by the graph databases, which means there has to be a very robust ETL pipeline. So basically, ETL means extraction, transform, and load. Extract is basically extracting the data, transform is basically processing or manipulating or enriching the data, and finally is the loading of the data, which is like updating the data to a graph database where it can represent the data in the format that we want. Finally, once the data is stored in the graph database, that is where we can run the machine learning models, for example, graph neural network, etc., which can then score the transactions. And finally, then there are alert mechanisms which can actually trigger real-time messages or alerts to the entity who needs to identify the graph, who needs to identify these fraudulent alerts that if a transaction is fraud or not. So yeah. So why exactly GNN? So now before we come down to the actual architecture, let's just highlight a few components that we discussed. So one is the graph neural network, which is GNN. Why do we focus on graph neural network in order to understand this transaction? So graph neural network are actually pretty good at analyzing relationships, which actually helps them much better for identifying the fraudulent transactions, specifically in case of graph databases. Secondly is around the neighborhood insights. Like we discussed that to identify whether a particular transaction is fraud or not, it is very important to examine that what are the peripheral transactions that are taking place. So, for example, if there is an entity that is transacting with some blacklisted entity, or if there are, let's say, 5 different accounts that are repeatedly transferring transferring some amount from region to region. So it is very important to identify what are the neighborhood transactions that are taking place, which is very easily, which is very good, which the graph neural networks are pretty good at identifying, and that's why they are able to uncover some hidden patterns, which are which are generally not easy for any kind of solution to identify, which is why the graph neural network in combination with event driven architecture is able to identify the real time frauds with much better accuracy. So the overall impact actually comes down to this only, that we are able to reduce the false positive, and we are able to do a real-time scoring and flagging of the fraudulent transactions that are happening. So reducing the false positive. So these are basically the two things that actually help any kind of fraud detection, because false positive, like I told, is one of the major issues which causes a huge amount of revenue and revenue loss for these companies, which could be in form of either the sanctions or the loss in terms of the amount that gets debited because of some fraudulent chargeback, etc. And it actually improves the customer experiences for the banks or entities. Now, if I describe the overall architecture, like how what we have discussed till now, in a simple graphical form, it should work something like this. That it works like this. That firstly, the event is triggered on an action on actions like login and transaction. So these events are basically integrated. Could be integrated like a web socket. Could be integrated like APIs or a webhook, etc. Into some of the like clients who are actually requiring the fraud detection solution. The moment an entity is triggered, there's an event streaming platform which actually takes the data, does a real-time streaming, and passes on to a solution which actually has the ETL pipeline. So ETL, which is the extract transformation load, it is able to instantly consume the data, process it into a format which can be converted into a graph database, and then enriches the database to add more contextual information. So, for example, let's say if there's a transaction that has happened with a customer, right? That okay, let's say there's a X amount of transaction that has happened, and then there's a device location that okay, this happened in this particular with this particular device, right? Now, since our solution is already adaptive and has a knowledge about the data that okay, this particular location tends to have a lot of fraudulent transaction with these set of devices, so it can actually enrich the data with these kind of information, or it can actually tell that okay, there are certain blacklisted entities which are into this area, and we need to add on to the information that okay, the second party which with the transaction is happening, is that a blacklisted entity or not. So once that information is added on, so firstly the ETL pipeline runs, it transforms the data. Then there is an enrichment of the data, which actually adds on more information. Finally, it is converted into a graph database, which is stored in Neo4j. Now, like I said, the how the structure of the graph database is going to look like is there going to be accounts. So account one will be linked to some other account, and they will be connected via the transactions that are happening between them. Now, this account could be a bank account, a credit card, or even a device from which the transactions are happening. Then based on the transaction, whatever the event has come up, the GNN algorithm actually scores the particular transaction based on the peripheral insight, based on the insight of the neighborhood transactions that are happening, based on the details of the transactions that are there, that okay, which device is it happening, which location it is from, and what is the customer history, right? Once based on this, once the GNN actually scores that okay, this particular transaction seems to be 75% or 83% fraudulent because of these reasons, then instantly an alert will be triggered. This alert will be sent directly to the entity where the transactions were given from, and that is how and this happens like in real time. So basically the entire process is able to instantly identify whether a particular transaction is suspicious, fraudulent, and is instantly able to trigger an alert for the company to act upon it. Now there's another important part which is around the narrations around it. So narrations basically like how do we so basically the previous the solution utilizes the event streaming architecture and graph neural network, but now with the addition of the generative AI solutions, the large language model, there are some much more advancements that actually can be done on top of that. So for example, for any now it is very important that when you identify any kind of transactions as fraudulent transactions, you need to also provide a narration along with it. Narration basically means a description in a very simple language, that if you have said this is fraud, why exactly it is fraud, right? Now, that is where the generative AI solutions can actually play a very good role, where they can actually understand, they can understand the transaction details. It can help in the ETL pipeline. It can help to create a narration document that, okay, this is a transaction with this much this much fraud score, and these are the set of reasons why exactly it's happening. So how that architecture actually plays out is, so first comes the data layer, where there are different multiple transaction databases. This transaction database, for example, transaction DB1 could be the account database, the transaction DB2 could be the third party database. Similarly, there could be like 7 to 8 different transaction databases which will store the data. Then the second layer, the other layer which is there, is the unstructured data. So there's a huge amount of data, for example, call recordings from these parties, the messages, the emails, etc. All this has been this comes into the ETL pipeline, where the data extraction, cleaning, and mapping takes place. Further, it is then embedded, like sent into the knowledge graph, and then there are certain like orchestration layer, like either llama index, langchain, etc., which is added on top of it, so that whenever a particular transaction gets flagged as fraud, you also get a narration around it, that okay, these are the reasons why it is fraud, and which makes it much easier to report the fraud timely to the authority, to the central authority of the particular country. So this is how basically the event driven architecture and the graph neural network play a very important role in timely identification of fraud, and also highlighting it to the particular authority of the country. So that's where we wrap it up. So thank you, everyone. If there are any questions, just do let me know. I can answer that.